Hello friends, in this session we will discuss about what are the different stages of machine analysis. I mean to say what has to be the flow chart in which the machines has to be dealt. Let's begin. Now see here, when we talk about analysis, what do we mean? We mean that you have a physically existing electrical machine and you have to represent the same on paper, right? So that you will be able to find the performance characteristics of the machine. You will be able to find out as to whether the machine will meet my requirements, right? Now in stage 1 we will be dealing with ideal machine analysis. Now here a student asked me, sir, what do we mean by ideal machine? Ideal machine means what? Machine in its purest form. What do we mean by purest form? Very simple. For any machine, if core losses, copper losses, non-linearities, leakage, etc. are neglected, then it means that we are going to analyze the ideal machine. Then that particular machine in which copper losses, core losses, non-linearities, leakage, etc. are neglected is called as ideal machine. But now the point is, any physically existing machine will have these parameters, will have some core losses, will have some copper losses, will have some non-linearities. Then should we neglect? Do we have the right to neglect those particular losses? No, because they are existing in the machine. Then who are we? Or basically who are you to actually neglect them? We cannot neglect them. That is the reason I am not going to say that they are neglected. Rather, I am going to say that they are not considered. So in ideal machine, core losses, copper losses, leakage, non-linearities, leakage, etc. will be not considered. Now, what is analysis, sir? Analysis means we will be analyzing the ideal machine at 1. No load, and next at some load. What load it is? Full load, half load, 10% of load, 20% of load, not interested. At load we are going to see how the ideal machine will work. So now once you have done this particular ideal machine analysis, then you will get some block like this. Let us say this is the ideal machine which you have analyzed. Means you are showing the physically existing machine on paper in the form of a block. For example, at the end of stage 1 you should get some block like this, right? Now next, now what will happen in stage 2, sir? Now in stage 2 what will happen, sir? Let's see. In stage 2 what we will be dealing with? In stage 2 we will be dealing with modeling of practicalities. Also called as building equivalent circuit. Means in this stage we will be building the equivalent circuit. Means what, sir? Whatever practicalities, like for example non-linearities, for example leakage, for example copper losses, core losses, will be represented on paper in this particular stage. In stage 2 we will be doing that. How we will be doing? For example, we know that leakage is, let us say, shown by a reactance X. Shown by a reactance X. Right? Now what I am asking, for example, you have a transformer 1 T1, let us say, and you have transformer 2, just for example, and this one has, let us say, the capacity of 100 MVA, and let us say ratio is 33 kV to 66 kV, and for example this one has, let us say, 500 MVA and 36, 33, and let us say this is 33 kV to 133 kV, for instance, right? So now you tell me what will happen here. This is transformer T1, this is transformer T2, having different capacities and it is having different voltage turns and all. So will the reactance which was modeled for transformer T1 be equal to the reactance which will be modeled for T2? Think about it. Of course they will not be equal. Means if in transformer T1 leakage is shown by reactance, then in T2 also leakage will be shown by using reactance only, but their values will be different. This is the reason we have to move for a stage 3. Now see here, in stage 1 you had, see here, in stage 1 you had got the ideal machine. Now you will have the practicalities like this. You will add the practicalities. Basically this can be a reactance or a resistance or anything, right? These will be among them. Basically resistances, capacitances and inductances will be shown here. Where they are shown, how they are shown, of what value they are shown, that we will see. Now once they are shown, for example this is reactance, let us say x1 for example, and let us say this is x2. Now here what will happen, see here, you know that leakage is been indicated or is been represented on paper with the help of reactance, but you don't know the value. That is the reason we will be doing stage 3. Now see here, in stage 3 what we will be doing, we will be finding the values of the parameters of the equivalent circuit. You will say, sir, but how we will find the parameter values? Very simple. The parameter values will be found out by indirect loading tests. In which we have OC test, we have SC test, we have, what do you say, dummy load test, polarity test, etc. Now these are the few tests which have to be performed on that particular machine so as to get the parameter values. Now you will ask me, sir, but why should we do this? Now you will ask me, sir, OC test, SC test, dummy load test, but then what is the need? Is there any other way? And other point was, see here, I talked here about indirect loading. Now student asked me, sir, what is the meaning of indirect loading test? We have understood that it will have OC test, SC test and all. But sir, what is the meaning of indirect loading test and direct loading test? Let us see. See here, when we talk about direct loading, it means that your machine will be directly loaded or it will be physically loaded. For example, you have a transformer, let us say that this is a transformer, right? Now let us say this is a single phase transformer for that matter. Now you know that this transformer input will be electrical and its output will also be electrical, right? Now this transformer is, for example, loaded like this. This is a physical load. Let us say this is a physical load. Now what is the problem here? Why are we not going to do this particular direct loading test? There is a reason for it. I'll tell you what is the reason and where is the reason. See here, when we are talking about load, for instance, this transformer, its rated capacity is, let us say, 10 MVA. Now you need to design a load which will absorb 10 MVA, which means your cost will increase, investment will increase. See here, very simple concept. You will have to design some load. You will have to design a load, right? You will have to design a load which will meet this 10 MVA requirement. Let us say if it is 100 MVA, what will you do? You will have to design that load, right? You will have to design a load which will meet the requirements of 100 MVA. Now, students say, sir, it's okay, na? 100 MVA only, sir. We'll directly design the load and will apply. No. It is not like that. What you need to have is the load has to be variable also. Means, for example, you need to find efficiency at, let's say, half of full load. Then if its capacity is, let us say, 100 MVA, so you have to design the load such a way that it should vary and its capacity should also be lowered to 50 MVA. I hope you are understanding it. See here, one more time. See here, what is the rated capacity? Rated capacity is what? 100 MVA. So first you have to design a load which will absorb 100 MVA, and then that load should also be variable at the same time. Means if I am asking the efficiency at, let us say, 50% of full load, which means the load has to be varied to its 50%, so that you will actually get the particular parameter values and all. For example, efficiency, right? So what you have to do, you cannot do this because that will be very, very expensive. Reason 1. Reason 2 will be what? Reason 2 will be logical reason. What is that? See here, second disadvantage is what? Whatever input I am giving to the transformer will be wasted. The power will be wasted. It will not be used. So this is the reason we cannot do direct loading test. This is the simple reason. So we will be going with indirect loading test. Means basically, if for example this particular transformer is, let us say, 100 MVA, you don't need to have 100 MVA of load. There is no need to have that load. Just by doing this test, OC test, SC test, dummy load test, polarity test, etc., doing those tests, you will get the approximate estimation of as to what will be the parameter. Say, sir, what do you mean by approximate and estimate and all? We don't understand anything. See here, when you do direct loading test, whenever you do direct loading test, you directly load the machine, you will get the real time parameters, you will get the real time values, you will get the real time efficiency, you will get the real time voltage regulation. But here, since you are not going to apply the load directly, that is the reason whatever analysis you do here, whatever parameters you get here, whatever values you get here, those will be estimated values. Values of efficiency, voltage regulation, etc. Those all will be what? Will be nothing but estimated. Basically, do you think that by OC test, SC test and all, you will get efficiency? No. From this, you will get the parameter values which will be shown on paper. Which values? These values. See here. These values, for example, this X1 is of how many ohms, whether it is 0.5 ohms or it is, let's say, 2.5 ohms, etc. Of what value it is, that you will get by the stage 3. Now, in stage 4. Now, in stage 4 means, now, in stage 4, what we will be discussing, we will be trying to find out what are the performance characteristics or performance analysis of the particular machine. Means performance characteristics or performance analysis. Student asked me, sir, what is the meaning of performance analysis? What do you mean by performance, sir? Very simple. Performance means efficiency, percentage voltage regulation, speed regulation, etc. These are nothing but the performance characteristics. Now, people ask me, sir, voltage regulation, speed regulation, efficiency and all, as to why we need them? Is there any need that we should know them at first before applying? Let us try to understand. See here. For example, it is a city. This is the city Mumbai. This is the city Mumbai, right? Now here there will be some areas which will be residential, some areas will be industrial areas, right? Some areas will be, let us say, somewhere around deep down there will be some agricultural area as well. Now, is this load fixed? No, 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 load is variable, but you know the capacity of this whole area. You know that what will be the maximum demand of this whole area, of this whole region, which means when you know what load you need, you will have to design the machine such that it will be able to meet the requirements of the load. Whatever machine you design should be able to meet the requirements of the complete area. For example, I am going to design a generator. Then this particular generator should suffice or should be sufficient to this whole region. And I should know it beforehand that yes, this particular generator can deliver this much amount of power. Why? Because you cannot ask the customers, sir, please on the tube light, on the fridge. You cannot do that, man. You cannot do it. That is the reason you should know it beforehand. So these performance characteristics are very important. One more performance characteristic is there. That is what? Torque speed characteristics, etc. Now, what do we do in stage 5, sir? Stage 5 will be very simple. In stage 5, we will be discussing about applications. See here. In stage 4, we did this. We know what we want, but how we will get it? We know that we need to find the efficiency. We know that we need to find the voltage regulation. We know that we need to find the speed regulation. We know that we need to find the torque speed characteristics. But how we will know them? How we will know them? So here is the reason. See here. What I will do from here to here is the ideal machine analysis, which will be done in stage 1. In stage 2, we will be finding as to what parameter I need to show on paper so as to represent that particular thing which is there in the physical machine. Means, for example, leakage is shown in terms of inductance. That we know. Now, in stage 3, we try to find out what? We try to find out the values of the reactances or the parameters. Then, in stage 4, we were going to find the performance characteristics. We know what characteristics we want. We know we need to find the efficiency. We know we need to find the speed regulation, voltage regulation, etc. But how will you find? You will simply apply network theory here. Apply network theory concepts. Network theory concept means what? Simple KVL, KCL, that's it. Here also we have to do the same thing. Apply network. This is how you will come to know about everything about the machine, ideal machine analysis. Then what the physical parameters are there, you are going to show them on paper like this. Then you know how to find the performance characteristics also. We have completed the stage 4. After stage 4, what we will do is, see here. Yes, see here. In stage 5, what we will do? We will basically discuss the application. Application in the sense, for example, application of a transformer will be auto transformer. You will be knowing that, in your Mumbai University syllabus or in any syllabus, if you see, the process is the same. After teaching transformer, teacher says, immediately try to learn auto transformer. Immediately learn three-phase transformer. Immediately learn parallel operation. Right, so basically they are what? They are nothing but in stage 5, and those we will see under the title called as application. After this stage 5, we are going to discuss stage 6. And in stage 6, we will be discussing about miscellaneous topics. Here, what are we going to study? Very simple. Magnetic inrush. Right. Then next, harmonics. So if you see, stage after stage, after stage 1, after stage 2, after stage 3, after stage 4, after stage 5, after stage 6, we will be able to get a grip on the complete machine. Whatever machine it is, whether it is transformer, synchronous, induction motor, DC, any machine it is, the steps will be the same, and we are going to do it with these steps only, so that you will get a clear idea. Stage 1, again, ideal machine. Stage 2 will be what? Parameters. Stage 3 will be what? Value of the parameter. Stage 4 will be what? Performance characteristics, like what? Efficiency, voltage regulation and all. Stage 5 will be application, and stage 6 will be miscellaneous. That's it. Thank you.